Today we'll be working on solving system of equations and inequalities graphically. Now let's go ahead and zoom in to number 1. In number 1, they're asking us to graph the system of equations. So the first thing you need to check is my equation written in the form y equals mx plus b? If that's the case, then you start by graphing the first line, you graph the second line, and then you check for a point of intersection. That point of intersection is going to be your solution. So let's go ahead and look at the first line. The y-intercept is 3. The slope is negative 3 over 4. So I'm going to start by plotting the y-intercept. And my slope is negative 3 over 4, so I'm going to go down 3 over 4, down 3 over 4, up 3 over 4, and so on. Now let's connect these points, and that's going to be my first equation. Now let's move on to the second equation, which is y equals 1/4 x minus 5. My y-intercept is negative 5, and the slope is 1/4. So I'm going to plot the y-intercept, and then I'm going to go up 1 over 4, and then up 1 over 4, down 1 over 4, and so on. If you connect these points, that's going to be your second line. Did these two lines intersect? Yes, they did. At 8, negative 3. That's the point of intersection. So that is going to be the solution. Now let's move on to part A. Let's ask ourselves some questions to make sure that we understand this problem. Part A, give an ordered pair that's a solution of color 1 but not color 2. So since I use the black color for my first equation, any point on the black line is going to be my solution. So 4, 0, 0, 3, and negative 4, negative 6, or negative 4, 6. These are points on my black line. So let's write maybe one of them, negative 4, 6. Now you need some points in part B that belong to the second line, which is the red color, but not color 1. So any point on the red line is going to be a solution. So negative 5, negative 6, 0, negative 5, and 4, negative 4. Any of these points is going to be a solution of the second line. Let's choose just one of them, which is 4, negative 4. Now you need the solution to both of them, and that's going to be your intersection, 8, negative 3. Now in part D, you want an ordered pair or a point that's not a solution to either equation. So basically any point that does not belong to the black or red line is going to be a solution of, or not a solution of either equation. So for example, negative 3, 0 is a point that's not on any of these two lines. So there you go. That's part 1. Now, so every single time you draw two lines, what could be the possible solutions? Now, if I draw two lines, they could be intersecting lines. In this way, they're going to be meeting at one point, and that's going to be your one solution. Or maybe you might draw two lines that they end up being parallel lines. In this case, these two lines will never meet. They will never intersect, and that's why you will have no solution. Sometimes you might draw two different lines, but they end up being the same line. They overlap. In this case, they are the same line, and you will have many solutions or infinite solutions. So these are the three options every time you try to solve a system of equations graphically. Now, how can we do this on the calculator? To do this, you need to go to y equals, and you need to graph the first equation in y1, and you type in the second equation in y2. Instead of doing alpha y equals and creating a fraction, you can just write 1 over 4x. It's up to you. Now, remember, you need to have them in the y equals mx plus b form, in the slope-intercept form, for you to be able to put them in the calculator. Now, once you have your y1 and y2, you hit graph. Great. Okay. So as you can see, the blue line is my first equation, the red line is going to be my second equation, and they do meet somewhere. In order to find the point of intersection, I hit second, trace, number 5, you're looking for the intersection, and then you hit enter 3 times. 1, 2, 3. And this is going to be your solution, 8, negative 3, and this is exactly what I found when I was doing it graphically by hand. This is how you do it on the calculator. Now let's move on back to our worksheet, and let's move on to number 3. In number 3, they're asking you also to solve graphically. Now if you look at the top one, you can tell that it's not in the slope-intercept form, so you need to isolate your y. So let me copy that equation. You start by moving x to the other side and you subtract x. Then you divide by negative 2. So y equals half x, and that's going to be your equation, because x over 2 is basically half x. And if you have a negative on the top of the fraction, negative on the bottom, a negative divided by a negative becomes a positive. So the answer is half x. Now the second one is already in the y equals mx plus b form. So I'm going to start graphing these two lines to find what the solution is. So the first one is half x, so the y-intercept is a 0. You go up 1 over 2, up 1 over 2, and so on, or down 1 over 2, and so on. You connect these points, and that's going to be the first line. Now the second line starts at negative 3, and then your slope is 2, so you need to move up 2 over 1, up 2 over 1, or down 2 over 1. You connect these points, and that's going to be your second line. As you can see, these two lines do meet at 2, 1, so that's going to be your intersection, or in other words, your solution. So what does it mean by solution? It means if you take the x equals to 2 and you plug it in the equation in any one of them, you're going to find y equals to 1. Let's try this just to double check. I'm going to plot x equals 2, so 2 times 2 is a 4, minus 3 equals to 1. There you go. I just found that y is equal to 1. This is how you can check your work. Or let me try in the other one. I just found that x is equal to 2, so y equals half times 2. Half times 2 is a 1, so there you go. I just found that y equals 1. So that's what it means. If you plug in x equals 2 in any of these two equations, the y will be equal to 1. So that's the first part of the lesson, which is solving system of equations graphically.